Hello and welcome to the show. I'm your host Abhijeet Sarkar. Today we're embarking on a journey to the intersection of cutting-edge technology and one of the most urgent missions of our time, preserving the health of our planet. We'll be diving deep into a field that sounds complex but holds immense promise for our future: GeoAI. So, what is this podcast about? It's about hope. It's about how we can use the power of artificial intelligence and data from space to tackle monumental challenges right here on Earth, from climate change and deforestation to protecting endangered species and managing natural disasters. The health of our planet is, after all, the health of humanity. Every forest cleared, every species lost, every degree of warming is a stark reminder of how interconnected we all are. In the next hour, we will demystify GeoAI. We'll explore what it is, how it works, and most importantly, we'll look at real-world stories of how it's already making a profound impact. We'll see how GeoAI is helping us monitor the retreat of glaciers in the Arctic, track illegal logging in the Amazon in near real time, predict devastating hurricanes, and even ensure that environmental policies are fair and just for all communities. This isn't a story about a distant sci-fi future. This is happening right now. So join me as we uncover the incredible potential of GeoAI and envision a future where human ingenuity and technological innovation work in harmony with the natural world. Segment 1. What is GeoAI? The basics. To start, let's break down the term GeoAI. It's a blend of two powerful fields: geospatial science and artificial intelligence. Let's tackle the geo part first. Geospatial data is information that is tied to a specific location on Earth. For centuries, we've made maps to understand our world. Today, we've taken that to an entirely new level. We have a fleet of eyes in the sky, satellites, drones, and aircraft constantly gathering information. They capture high-resolution images, measure temperatures, track land changes, and collect a treasure trove of data about our planet's physical, chemical, and biological systems. This entire process is called Earth observation. Add to that a network of sensors on the ground in our oceans, forests, and cities, and you have an unimaginable amount of location-based data. Now for the AI part. Artificial intelligence, particularly machine learning and deep learning, gives us the ability to make sense of this colossal amount of data. A human analyst could spend a lifetime trying to sort through the petabytes of satellite imagery we collect. And AI, on the other hand, can be trained to sift through it in minutes. It can learn to identify patterns, detect anomalies, and make predictions that would be impossible for a human to see. So GeoAI is the marriage of these two. It's about teaching intelligent algorithms to understand the language of our planet as told through geospatial data. Think of it like this: we're giving a super intelligent brain access to 1,000,000 eyes that are watching our planet 24/7. This brain can then tell us there's a fire starting in this remote part of the Amazon, or this coastal area in Miami is becoming more vulnerable to flooding, or the air quality in this part of the city is declining rapidly. This transforms Earth observation from a passive data collecting exercise into an active, real-time monitoring and predictive system. It's the difference between looking at a photograph of a problem and having a live video feed that also predicts what will happen next. This is the foundational power of GeoAI, and it's what allows us to tackle the planet-sized challenges we face today. Segment 2. GeoAI in action, monitoring our changing climate. Perhaps the single greatest threat to planetary health is climate change. Its effects are vast and varied, and understanding them is the first step towards mitigation. This is where GeoAI is becoming one of our most vital tools. Let's look at a few key climate indicators and see how GeoAI helps us track them. First, let's talk about temperature variations. We know the planet is warming, but by how much and where? GeoAI helps us answer this with incredible precision. AI models analyze decades of satellite thermal data to detect temperature anomalies. For example, research has used GeoAI to confirm that the Arctic is warming at more than twice the rate of the rest of the world. These models can pinpoint specific areas of accelerated ice melt and permafrost thaw, giving us a much clearer picture of the feedback loops that intensify global warming. Next is sea level rise. As glaciers melt and ocean water warms and expands, our coastlines are under threat. GeoAI processes data from satellite altimeters, instruments that measure the height of the sea surface, to track this rise with millimeter accuracy. A case in point is the work being done to assess coastal vulnerability in cities like Miami. AI models combine sea level data with land elevation maps to predict which neighborhoods are at the highest risk of chronic flooding. This allows city planners to design targeted adaptation strategies like building seawalls or restoring natural mangrove barriers to protect these vulnerable communities. Of course, we can't talk about climate change without talking about carbon emissions. GeoAI is revolutionizing how we track them. Traditionally, we relied on self-reported data from countries which can be inconsistent. Now, satellites like NASA's Orbiting Carbon Observatory 2 or OCO2 can measure carbon dioxide concentrations in the atmosphere from space. AI algorithms analyze this data to identify and quantify emission hotspots, whether it's from a specific power plant, an industrial zone, or even a city. A collaboration between the European Space Agency and the startup GHSat uses this exact approach to detect methane leaks, a greenhouse gas far more potent than CO2, from oil and gas facilities, helping companies and regulators plug these leaks faster. Finally, we have the dramatic visual evidence of climate change: glacial retreat. GeoAI models analyze sequences of satellite images from missions like ICESat-2 to measure changes in ice thickness and volume. A study by researchers at the University of Cambridge used deep learning to analyze the Greenland ice sheet. The AI model not only identified significant ice loss, but also predicted future melting rates based on historical patterns. This data is critical for refining our global sea level rise projections. In all these spaces, GeoAI is not just giving us data, it's giving us clarity and predictive power, turning raw information into the urgent knowledge we need to act. Segment 3. GeoAI in action, protecting our precious ecosystems. Our planet's health is also measured by the vitality of its ecosystems. Forests, oceans, and the incredible diversity of life they support are under immense pressure. Here again, GeoAI is providing new powerful ways to protect them. Let's start with our forests, the lungs of our planet. Deforestation continues at an alarming rate, but GeoAI gives us the ability to fight back. Platforms like Global Forest Watch use AI to analyze satellite imagery from Landsat and other systems in near real time. The algorithms are trained to detect the telltale signs of forest clearing. If a patch of Amazon is illegally logged, the system can send an alert to authorities within days, not months or years. This allows for rapid intervention. Furthermore, GeoAI can detect more subtle forest degradation like selective logging or fire damage that might otherwise go unnoticed, giving us a more complete picture of forest health. This same technology is crucial for biodiversity and wildlife conservation. To protect a species, we first need to understand where it lives. GeoAI helps us create highly detailed habitat maps. By analyzing land cover, vegetation, water sources, and other environmental factors from satellite data, AI can identify areas that are critical for the survival of specific species. Once we know where they live, we can track them. Many of us have seen documentaries where animals are fitted with GPS collars. GeoAI takes that data to the next level. For example, researchers tracking elephants in Africa use AI to analyze their movement data. The models can predict migration routes, identify corridors between protected areas, and pinpoint where elephants are most likely to come into conflict with human settlements. This allows conservationists to work with local communities to create safe passages for wildlife and reduce conflict. And critically, GeoAI is a powerful ally in the fight against poaching. Drones equipped with thermal cameras can patrol vast national parks at night. The video feed is analyzed by AI that can distinguish between animals and humans. If it detects a potential poacher, it instantly alerts park rangers, giving them the location and allowing them to intercept criminals before they can do harm. Finally, GeoAI helps us monitor broader land use changes. As our cities expand and our demand for agricultural land grows, natural habitats are often the first to go. GeoAI tracks this expansion, whether it's urban sprawl or the conversion of forests to farmland. This information is vital for sustainable land management, helping planners balance human needs with the preservation of natural ecosystems. It helps answer the critical question, how can we grow without